question at hand involves the installation of a new 300 kV uninterruptible power supply, or UPS, to replace an existing unit of the same size. The manufacturer is proposing a unit that does not have an overcurrent device on the output circuit. The manufacturer argues that the output cables are protected because the UPS electronically senses overloads and faults and switches to the bypass circuit within a half cycle. The bypass circuit then clears the fault by way of the upstream feeder breaker. National Electrical Code, or NEC, Section 705.15 subsection B addresses separately derived systems. Separately derived systems require protection against overcurrents as provided in NEC Article 240. NEC Section 240.13 states that overcurrent protection shall be provided to protect conductors and equipment from overheating due to overload or fault currents. While the UPS may electronically detect overloads and faults, this electronic detection is not a substitute for traditional overcurrent protection devices. The bypass circuit is intended for temporary operation during the UPS maintenance or failure, and it may not provide the same level of protection as dedicated overcurrent devices. Without dedicated overcurrent protection on the output circuit, the coordination between the upstream feeder breaker and the bypass circuit may not be optimal. Despite the manufacturer's argument, it is generally recommended to install dedicated overcurrent protection on the output circuit of a UPS, even if it has built-in fault detection. This ensures compliance with NEC requirements and provides a consistent level of protection. If the manufacturer's claim is valid, installing an overcurrent monitoring device can provide an additional layer of safety by alerting users to potential overcurrent conditions. It is important to coordinate the overcurrent protection devices with the upstream feeder breaker and the bypass circuit to ensure proper operation and selectivity. Firstly, consider NEC Section 240.4, which provides the requirements for the protection of conductors. Conductors must be protected against overcurrent in accordance with their ampacities, subject to certain exceptions for specific applications. Secondly, the interrupting rating of overcurrent protective devices must be sufficient for the available fault current at their terminals as per NEC Section 110.9. Thirdly, NEC Section 408.36 requires overcurrent protection for panel boards. Each panel board must be protected by an overcurrent protected device with a rating not exceeding that of the panel board. Fourthly, if the UPS is feeding critical loads, consider NEC Section 700, which covers emergency systems. Emergency systems require additional considerations for overcurrent protection to ensure reliability. Fifthly, NEC Section 701 applies to legally required standby systems. Like emergency systems, these may have specific requirements for overcurrent protection. Sixthly, the overcurrent protection must be readily accessible as per NEC Section 240.24. This ensures that it can be easily inspected, tested, and maintained. Seventhly, select overcurrent protective devices that are appropriately rated for the voltage, current, and frequency of the UPS output circuit. Eighthly, ensure that the overcurrent protective devices are listed and labeled by a recognized testing laboratory. Ninthly, a short-circuit coordination study is essential to determine the appropriate size and type of overcurrent protective devices. This study ensures that the devices will operate in a coordinated manner to minimize the extent of any outage. Tenthly, maintain documentation of the overcurrent protection scheme, including device ratings, settings, and coordination study results. This documentation is useful for future reference and troubleshooting. Considering the technical aspects of the UPS, understand that the manufacturer's claim of electronic overload and fault sensing relies on the UPS internal monitoring system to detect abnormal conditions. This system typically uses current transformers or other sensors to measure the output current. When an overload or fault is detected, the UPS is designed to quickly switch to the bypass circuit. The bypass circuit is a direct connection to the upstream power source, bypassing the UPS inverter and other internal components. The speed of this transfer is critical. The manufacturer claims that it occurs within a half cycle, which is approximately 8.33 milliseconds on a 60 Hz system. This rapid transfer is intended to limit the duration of the fault current and prevent damage to the UPS and the connected loads. However, relying solely on this electronic protection mechanism has several potential drawbacks. Firstly, the electronic detection system may not be as reliable as traditional overcurrent protective devices. Electronic components can fail, and the detection system may not always operate as intended. Secondly, the bypass circuit may not provide the same level of protection as dedicated overcurrent devices. The upstream feeder breaker may be sized to protect the entire load served by the feeder, not just the UPS output circuit. As a result, it may not trip quickly enough to prevent damage to the UPS output cables or connected loads. Thirdly, the coordination between the upstream feeder breaker and the bypass circuit may not be optimal. Without dedicated overcurrent protection on the UPS output circuit, it can be difficult to ensure that the upstream breaker will trip before the UPS is damaged. To address these concerns, it is generally recommended to install dedicated overcurrent protection on the output circuit of the UPS, even if it has built-in fault detection. This can be accomplished using a circuit breaker or fuses. The overcurrent protection device should be sized to protect the UPS output cables and connected loads in accordance with the NEC. It should also be coordinated with the upstream feeder breaker and the bypass circuit to ensure proper operation and selectivity. In addition to dedicated overcurrent protection, it may also be beneficial to install an overcurrent monitoring device in the UPS output circuit. This device can provide an additional layer of safety by alerting users to potential overcurrent conditions. The monitoring device can be connected to an alarm system or a building management system to provide real-time notification of overcurrent events. To ensure proper coordination of the overcurrent protection system, a coordination study should be performed. This study involves analyzing the fault currents of various points in the electrical system and selecting overcurrent protective devices that will operate in a coordinated manner. The goal is to ensure that the overcurrent device closest to the fault will trip first, minimizing the extent of any outage. The coordination study should consider the characteristics of the UPS, the upstream feeder breaker, the bypass circuit, and any other overcurrent protective devices in the system. It should also take into account the potential for future load growth. In conclusion, while the manufacturer's argument for eliminating dedicated overcurrent protection on the UPS output circuit may have some validity, it is not sufficient to eliminate the need for such protection. Dedicated overcurrent protection is essential to ensure compliance with NEC requirements and to provide a comprehensive level of safety for the UPS, the output cables, and the connected loads. It is also important to consider overcurrent monitoring and coordination studies to further enhance the safety and reliability of the electrical system. One must carefully evaluate the manufacturer's proposal in light of the NEC requirements and best practices for overcurrent protection. One should prioritize safety and compliance and consider the long-term reliability of the UPS and the electrical system. By installing dedicated overcurrent protection, performing coordination studies, and monitoring for overcurrent conditions, one can ensure that the UPS operates safely and reliably for many years to come. The NEC provides a framework for ensuring electrical safety, and it is important to adhere to these requirements when installing and operating electrical equipment. Specifically, NEC Section 110.3 subsection B requires that listed or labeled equipment be installed and used in accordance with any instructions included in the listing or labeling. If the UPS is listed and labeled, the installation must comply with the manufacturer's instructions, which may include specific requirements for overcurrent protection. NEC Article 240 provides detailed requirements for overcurrent protection. This article covers the selection, installation, and coordination of overcurrent protective devices. It also includes requirements for the interrupting rating of overcurrent protective devices, which must be sufficient for the available fault current at their terminals. When selecting overcurrent protective devices for the UPS output circuit, it is important to consider the specific characteristics of the UPS and the connected loads. The overcurrent device should be sized to protect the UPS output cables and connected loads in accordance with the NEC. It should also be coordinated with the upstream feeder breaker and the bypass circuit to ensure proper operation and selectivity. The interrupter rating of the overcurrent protective device must be sufficient for the available fault current at the UPS output terminals. This can be determined through a short circuit study. The coordination study should also consider the time current characteristics of the overcurrent protective devices. The goal is to ensure that the overcurrent device closest to the fault will trip first, minimizing the extent of any outage. The coordination study should be performed by a qualified electrical engineer. The results of the coordination study should be documented and made available to the facility's electrical maintenance personnel. In addition to dedicated overcurrent protection, it is also important to consider the grounding of the UPS system. The grounding requirements for separately derived systems are covered in NEC Article 250. The UPS should be grounded in accordance with these requirements to ensure electrical safety. Regular maintenance and testing of the UPS and its overcurrent protection system are essential to ensure continued reliability. The maintenance program should include periodic inspection of the overcurrent protective devices, testing of the UPS batteries, and verification of the UPS internal protection functions. The testing should be performed by qualified personnel using appropriate test equipment. The test results should be documented and used to identify any potential problems. By following these recommendations, one can ensure that the UPS operates safely and reliably and complies with NEC requirements.